In previous videos, I've been talking about the product binomial when we have two samples and a dichotomous response variable. But what about if we go beyond two samples or beyond two categories for our response? The product binomial provides an exact test of proportions when sample sizes are fixed in advance for two samples and the response variable is a dichotomous variable. This can be extended to more samples or more response categories. While the method is straightforward and simple, it becomes cumbersome to generate a complete distribution in these situations. For more than two samples, we have more than two samples that are independent of one another. The observations within those samples also need to be independent of each other. And we have a dichotomous response variable, just like we had when we looked at the two-sample product binomial. So the null hypothesis is that the probability of success in the first group is equal to that in the second, is equal to that in the third, and so on, all the way up to the kth group, where you have k different groups. We can again use the product binomial, but instead of having a product of two binomials, we would have a product of k binomials. If you read the article that accompanies this video, I attempt to do an example and you'll see how it quickly becomes rather cumbersome. Nonetheless, theoretically, we can use the product binomial, taking a product of k terms, in order to test the equality of the probability of success among k samples. What if we have more than two response categories? That is, two or more independent samples, independent observations within samples, and an unordered categorical response variable. The null hypothesis here is that the proportion that would fit in a particular response category is the same across all k samples, and that's true for all response categories. In this null hypothesis, we have k samples and up to j response categories. As I've discussed in past videos, the multinomial function is an extension of the binomial function. So we can use a product multinomial just like we can use a product binomial, taking the product of k terms. Again, with more samples or more response categories, this can become some heavy lifting in a hurry. So we better look at the large sample approximation. And here's the good news. With large samples, all multinomial exact tests, including binomial exact tests, because the binomial is a special case of the multinomial, can be well approximated with a chi-square distribution with k minus 1 times j minus 1 degrees of freedom, where k is the number of samples and j is the number of response categories. This is why for just about any contingency table that you will encounter in the research literature, you see a chi-square done rather than an exact test. The exact test is doable and should be considered when we have small sample sizes, but once we get large sample sizes, the exact test can become extremely unwieldy, and the chi-square test provides a good approximation.